Solving position, velocity, and acceleration problems from an equation is very much like doing graph analysis with f prime and f double prime from an equation. The difference is we have to know what it's asking for. So here when a particle is moving left, we just have that memorized. That means velocity is negative. And let's do our charts so that we know what we're working with. So we got position, velocity, acceleration, so this is f double prime, f prime, and f. So we're interested in when velocity is negative, so these always start at 0 for time. So all we need to do is go ahead and fill in this line. Remember, we can only work with positive and negative lines when we have equations, but conveniently enough, that's what we need for this one. So the first thing that we're going to need is velocity, because we're working with velocity. So starting with this, s of t we take the derivative, because the derivative of position is velocity. Go ahead, do our sign chart. Oops. So that tells us that at time t equals 1 and t equals 2, this will be 0. If we do our sign chart at 0, those both be negative, so negative times a negative is a positive. Between 1 and 2, we're going to have, let's see, 1.5 minus 2, that's negative, and a positive, and then after 2, they're both positive. Okay? So that means when is the particle moving left? When t is between 1 and 2 seconds. Negative. And there we go. How about when is velocity increasing? Well, coming back over here again, we want velocity to be increasing, decreasing. We have to work with a plus-minus line. So that means that we're going to need to fill in the positive and negative line for acceleration. We know acceleration is the derivative of velocity. So we'll start with v of t. And we'll take the derivative of that to get acceleration. So t is 3/2 or 1.5. So let's see, it looks like if t is very small, so getting on towards 0, that's going to be negative, afterward positive. So that means decreasing, increasing. When is velocity? Oops, I should show you where that is. So here we used acceleration down here to fill in our positives and negatives, fill in our increasing, decreasing for velocity. And our answer is when, let's see, we were looking for increasing, when t is greater than 1.5 seconds, because acceleration is positive. Okay, how about we say when is the particle at rest? We have to remember what this is. This means velocity is 0. So we come up here. Do we already have that for velocity? Well, velocity is 0 when it changes from positive to negative and vice versa. So at 1 and 2. How about when is acceleration negative? Do we already have that? Yes, we do. Just had to go to the acceleration positive negative line and read it right off there. Acceleration is negative between 0 and 1.5 seconds. Since we got that directly off, we just sort of calculated and wrote that plus minus line. There's no additional justification needed for it. Sometimes we have one that is particularly interesting. What is the maximum acceleration? So what that means, if we come over here and we've got position, velocity, acceleration, I'll rewrite that. We've got all our lines. We want maximum acceleration. So that's this line right here. But the thing is that we need a positive and negative line for it. So if this is f, and this is f prime, and this is f double prime, we know that this over here, increasing, decreasing, corresponds to concave up, concave down, corresponds to nothing. Increasing, decreasing corresponds to a positive, negative line to the left. So if we look back at our little chart, we see that pattern here, right? The increasing, decreasing, if we want to get a positive, negative line, we have to go left. So right now we're at f double prime. There isn't really like a listed like positive, negative, 0 box over here, but it's implied by this pattern that we have here. So if we just go down to the third derivative, so this would just be the derivative of acceleration. It doesn't have its own name. We can figure out where the derivative of acceleration is positive and negative, and correspondingly when the acceleration is positive and negative. So if I come back to here, I know that acceleration is 12t minus 18. The derivative of acceleration then, so let's label this a prime of t, is going to be 12. So that means that this is always positive, this is always increasing, and increases forever, so I think I ought to have some bounds on here. What is maximum acceleration on the interval 0 to 5. So let's bound this at 5. Well, acceleration is increasing forever, so that means that right here is going to be our maximum value. Oops, let's bring that back. And notice that this asks for the actual value of it. What is the maximum? A of 5 is 12 times 5 minus 18. 42. And let's see, our original position was in meters, time is in seconds, so acceleration units are meters per second squared.